All right, we're gonna do a review of 14 and 17, and then we'll talk about the midterm on Monday. Good.
I forgot to say, but the last week's or Monday's thing wasn't posted.
Really?
Yeah. I was trying to figure out how to do it. I think I did it like way wrong.
I recorded that though, I think, didn't I?
Yeah, you did record it.
Yeah, okay,
It wasn't posted.
all right. I probably forgot or something. That's weird because I sure thought I did that. All right, well, hopefully we'll get this one loaded. So 14 says, we probably should have read it in class because I could have given you hints on this. A reservoir discharge, 60-inch concrete pipe, rough surface. So rough surface gives us what for the roughness factor? Yeah, if you guys have numbers, it'll go faster.
It was asking for pressure.
Concrete pipe, rough surface, roughness factor is concrete pipe. Yeah, I know. 0.010 for roughness. 010, that's from that table. So first thing I do is I just collect information, right? I know I'm gonna need that. I know I'm probably gonna have to run Movie's diagram because it does say consider friction, correct? Yeah, consider friction, neglect minor losses. Remember, minor losses are gonna be like entrance losses, which we haven't even dealt with yet, but that's why they're saying that. All right, so we have a 60-inch pipe. I got that. Rough surface, I have the roughness factor. Discharges freely. So when it discharges freely, the pressure here is 0, but the pressure here exists at A. It's inside the pipe. Okay. So in order to do this problem, we have to run this equation. But if I start at A, I'm going to have a velocity, an H1, so I could get that. A velocity 1 is 0, so this is going to go away. An H2, I could get that from trigonometry, which we'll have to do at some point. You probably already did. P2 is going to be there, and V2 is going to be there, but I don't know the velocity, right? And I have to do the friction factor, and I don't know any of this. So I can probably find this out if I knew V2, but I don't, right? I don't know this velocity here. I don't know the velocity here. So what you have to do first is find the velocity at the exit, because the velocity in the pipe is the same throughout the pipe. And that's the problem that we just did, is finding the velocity at the exit. Once I have V2, it's going to be the same at A, because the velocity in the pipe is consistent throughout the pipe.
How does that help us find pressure?
Well, then we can do this equation here because we'd have V2 and P is the only things I know. Because we'll have this. Yeah.
Okay.
So that's, if I would have just gave you that information. Yeah, we should have read it in class. That's my fault. I was like, oh, looking at that this morning, went, oh, well, I bet they don't figure that one out. So the first thing you got to do is you got to find V2. So you set it up just like we did before. Once you have V2, it's the same here because it's the same throughout the pipe. Then we can go after this using this equation and putting in the pressure. Okay. So hopefully you got some information for me. I know I'm H1 at 268 feet. I know V1 goes away because the velocity here at station 1 is 0. So that's going to equal, now I need H2 down here at the bottom, which is 221.12. Again, this is find V2 because V2 is also here, and that eliminates that variable when I go for pressure here. So we're working down here first to find V2. All right. P goes away because I'm down here at the opening of the pipe. So I'm going to actually put in the +0 for that. I don't know V2 plus V2 squared over 2G. And I do have to consider friction. So how do I get F? Moody's diagram, right? But we don't know velocity. So what do? We don't know velocity and we don't know F. What we did in last class is we
factor out.
make a guess.
Oh, yeah.
So we make a guess at that friction factor, right? We need velocity, right, to get Reynolds number, so we can't use Moody's diagram. So in order to use Moody's diagram, we make a guess at this friction factor. So remember, we have to set that equation up, which we're doing right here. And they walk you through it in this example problem that we did before. That's why I used that example problem. If I can find it. Yeah, it's here. Example 4.2. So here's where they set it up to find it. And you get H1, H2, which we have in there, the velocity, and then you factor it out. So it ends up to be H1 minus H2, 1 plus, right? And then you got to get L in there and D. So you can use this little equation right here. Whoops, right to the bottom. This little, remember when you factor out the V2, 2G? So they factor this out. Can I capture it? Yeah, like that, right? That gets factored out and pulled out here. When you do that, you're essentially dividing this by that, the same thing, and it creates the 1. So that's just the algebra factoring. This equation works good. We can use this equation right here. And then actually, once you get L and D in, then the 175 changes to whatever it is for your problem and the 2 H's. So I'm going to use that. I'm going to pull it off screen here. It's page 62. So ours is going to be 268 feet. That's H1 minus H2. And then I'm going to write their equation as 1 plus F. And then it is L, the length. So I got to have that length. Well, I need the length of the pipe. 1425 is the horizontal. Really? Did you get a length of pipe, Nick? Not that I don't believe you, Brian, but I can't believe that's that close to the horizontal. All right, so what's the, oh yeah, you're right, it only drops down. How far? 21.38. So you square rooted 1425 and 21? Or squared both those and then square rooted? Wow, that's surprising to me. All right, what's the number? 1,425 feet. So that's the length. Oh, 0.16. Okay. Yeah. 0.16 over the diameter 5 feet. So I'm just using their equation that they created for us, and I'm using it right here. So I'm putting L over D. I'm leaving F in there, right? And then I'll put in the 64.4. And it boils out to this, but I just don't know what that ratio is yet. So diameter of the pipe goes under, so that's where the 5 feet is. This looks like it's to a factor, but it's not. Then all of that, V2 squared over 64.4. Again, I'm just boiling this down, gonna do the division. This is setting up the equation that we can run the trials with. I have no calculator. That's disappointing. All right, guess I got a phone with a calculator, don't I? Crazy. So 425, 1425.16 divided by 5. So this is 285. 32, yep. And then I'm gonna actually multiply the 64.4 over. Remember, it gets multiplied over here. $17,259. Point 2, 1 plus F 285.
You didn't minus the 221.12 from the 268.
Oh gosh, I didn't.
That number-
Oh man, I need you guys. That number changes a lot.
Yeah, the 46.88.
268. Yeah. $46.88.
Number at the bottom would be 3,019.
Yeah, and then that gets multiplied by the 64.4. $3,019.
Yeah. Oh,
All right. Now we can start to run our trials. All this just to get the velocity, right? What we're doing, trying to get that velocity, because we know the velocity in the pipe is consistent. All right, what do they use for their starting?
0.02.
Yep, 0.02. So we're gonna guess. Per friction factor of 0.02. Plug that in. Come up with the velocity. That allows us to run Moody's diagram.
Velocity of 54.89.
Anybody else running it? 54.89. I'm gonna try to run it, but
On that right side, we end up getting like 6.70064.
yeah,
And then you just minus that on the other side.
yep.
You square root.
0.02 times 2.032 equals +1. So I got 6.70064. Anyone else get a velocity yet?
I had no idea what I was doing, so I'm still.
Okay, so what we're doing, we're guessing at 0.02.
Yeah.
For that. Right?
Yeah.
That's why we set this up. So once we know that, then we can take 0.02 times that plus 1, divide it into that and get velocity by taking the square root. Right? That's what we want to be doing. And I want to verify Brian's number. What'd you get, Brian, for velocity? I think it's good.
4.89.
So see if you can get that, Nick. Both.
Looking at 0.02.
Yeah, it's just my freaking calculator. I can't do it. I have to save every number. I can do it. 3019.
What pipe was it? Do you remember?
Rough, concrete rough. So now I need the square root of this creature. I get 21. That's a problem for my
That's what
velocity.
I got too.
For velocity. Did you add the
What
one?
number did you get on the right side? Like when you like put in the
450. That you're taking the square root of? Did you add the one?
Yeah, no, I was like, what number when you plug in 0.02, like on the right side of the equation, right? Because you're doing 285.032 times 0.02 plus 1, right?
Yeah.
And the number I got from that was 6.7.
Yep, 6.7 divided into 3019 is 450.
I got 6.7, right?
Yeah, I
And
did
then you
too.
take that.
Yep.
And you minus it from the left side.
No. This is a multiplication. So this is a plus, right?
Oh, you got it.
You have to divide it. Yeah. So I get 21.2264. All right. Now we can get Reynolds number and we can get the other right side of the Moody's diagram. I can find the Moody's diagram. There it is. So I'm gonna go Reynolds number. Remember, that's diameter, velocity, viscosity. Diameter is 5. And now our viscosity is 1 to the minus 5. Anyone get a velocity or a Reynolds?
10,610,000.
So 10 to the e to the 6. 10 point,
If you do 1.06, then that'd be 10 to the 8.
that was 10 to the 8 on the chart.
What number did you get?
I did not get that number. Should be 5 to the, yeah, 5 times 21.2264
It's 106.1.
divided by,
Yeah. The 10 to the -5.
I think it's 1 to the -5. Is it 10? Nick and Nick? Anybody?
Yeah, it's 1 times 10 to the -5.
Yeah, not 10.
Oh, yeah, 1 times 10 to the -5.
Correct.
Point 0.001061.
For velocity? Remember, it's gonna
No.
go way up if you divide by it.
Just for the, this is for the ground.
Yep.
106.1 divided by that 1 times 10 to the -5.
So it should be 5, 21.221 e to the -5. I'm getting 2.122 10 to the 6. But I want to verify because I have a funky calculator. Oh, you're getting the same thing Brian's getting. Yeah, that makes sense because I got 106.1 on top and then it's just going to be moving the decimal point. Right? Yeah. So divide, oh, that's not true because we are dividing by, no, that is true.
But I think it's the 10,610,000 number.
Yep.
I just got it again.
So give it to me in like 10.
10, 61, and 4 zeros.
So give me in scientific notation.
Oh,
10.61 e to the,
6.
yeah,
6, yeah, I think
I think that makes sense. Because that's what's on the graph. So then we also need the roughness factor. That is our 0.010 for rough concrete over 5. So 0.002. I call that the RR number. This is the NR number. This is the relative roughness. And then we can go for Moody's.
What do we want it in 1.06 times 10 to the 7? Instead of 10 to the 6, or like 10.6 to the,
Yeah, probably. Yeah.
just add 1.
Yep, because we don't have 10 on the thing. You're correct. So we can't get 10.61. We can get 1.06 to the 7. So 1.06 to the 7.
Follow that 10 to the 7 straight up, right?
Come on, focus. There we go. Yeah,
Oh, I guess I can plug it into the,
you could, yeah, I was gonna put a link to that. We have a 0.002. You should plug it in and then I'll see what I get. So my guess would be below half, so like 0.024.
0.0234.
That's pretty fun. So my guess is 0.024, and the online table says what?
0.0234.
Yeah, that's pretty good. Not bad at all. All right, so we'll use the Max's online 0.0234. And now we're going to plug that in and get another velocity. And that'll probably be our correct velocity. All right, this develops a new velocity of 19.84. So that is less than the 2122, but pretty close to it. So that's how this thing is zooming in. Oh, weird. I don't know about
Yeah,
sound.
that's the number. Friction. One is 0.0234.
Did we get a new Reynolds?
9.92.
E to the 6?
We use like the back in and gave me the same friction factor.
Give you the same friction factor when you went back to the table.
Yeah.
So Reynolds number from our new velocity, 9.92 e to the 6. We use the same relative roughness, plug it into our online calculator, it gives us the same 0.0234 friction factor. So
It's the interesting back to look, right?
we got it, but we're not done.
Oh, yeah.
Yeah, remember this? That was just to find the velocity. The 19.84. That's what we needed, 19.84. Right? Now we have to find the pressure. So I need maybe a new piece of paper. So we have found a few things that we need. And we know our velocity here is 19.84 feet per second. We know we're 268 at the top. We're 242 here. We are 550 over to our point, but we don't know that spot. But we do know the length at the bottom, 1425, and an elevation there of 221.12. We kind of need all that because we need our H here at the 550 mark. So we have to do some trigonometry to get that. Right. We can use this big triangle here to calculate the elevation down, right? 221 from the 242. To give us that height. Because we have similar triangles here. One there, one here. So we've got to solve those similar triangles to figure out what this elevation is at point A. That's where they want to know the pressure. That whole first part that we did, that was just to get the velocity. And it also gave us the friction factor, right? 0.0234. So we know our friction factor is 0.0234. We got that from that whole first shenanigans. So 221.12 from the 242. $20.88. So from here to here, 20, oh geez, 20.88 feet is our height. Right? So you can do, we want this distance, I'll call it Y. That's the distance we need. So you can just set up ratios. 2088 feet to 1425 is Y to 550. Y equals. Yeah.
8.06, I think.
Yep. So then we add that to the 242 to get our elevation here at A. Excuse me, we subtract it. Subtract it.
The 233.94. The new elevation of A.
Yep. And we need that for our formula. Because we need H1 and we need H2. Two, 4, 2 minus 233.94. Yep. Check it out. It even looks like an HP on my phone. Yeah, it's just the buttons are really, really small. But I'm a little happier. All right, so now let's set up the formula. It's gonna write it out one more time. So when we consider friction, we have this piece, and it does say consider friction, but we now have that, so that's good. And we also have that velocity too. So all of those are solvable. This is solvable, this is solvable. We know H1, we know H2, we know the starting velocity goes to 0 because that is up here at station 1. The only thing we don't know is P2. And actually, I'm going to write it as P at point A. That's what we want out of this problem. So we could not do this in the beginning because we did not know the velocity and we did not know the friction factor. So we had to do that first trial and error system to get that. But now we know H1, 268. I'm just going to pull H2 over, or HA, 233.94, because those always get subtracted from each other. PA over, what's the specific weight of water?
62.4, right?
Yep, 62.4 pounds per foot cubed. Plus our velocity, which is 19.84. That gets squared.
So wait, now when it's asking for a length though at the end, it's asking it from the. top of
Yes,
A,
yeah. This L is gonna go from here to here.
Okay.
Yep. So we should be able to get that. Over 2G, which is 32.2, 64.4, 2 times 32. Plus friction factor 0.0234 times our length, which is going to be the squaring of the 550.
It's 550.06.
Perfect.
Because it only drops.
Yep.
8 feet over 550.
Our velocity squared 19.84 squared. Our diameter 5 feet. And then 2G, which is 64.4.
It's 550.1.
Oh, six.
So I'm just gonna boil some things down into numbers. Get all this as a number, get this as a number. Then all of that gets subtracted from this side. And then we can divide this 62.4. All right, here's my numbers, and then I get a pressure. What do you get?
I got 786.54.
For what? What kind of unit?
Pounds per square.
You
Wait,
get-
what did you get?
I got a small number.
Then you do 62.4 times 12.
62.4, what's this? Pounds per cubic foot. So it's in the right unit.
But then you times that number by 12.2.
Yeah. I divided. Yeah, it should go up, way up. Glitching. $62.4 times 762. What's the book get? Oh, man, that's gonna be disappointing. I don't even know where those solutions are back here. Trying to find them. Are they in the very, oh yeah, they're in the very, oh, that's right, my page is tore out, I don't have it.
Chapter 4, problem 14.
Yeah.
Is not in the book.
Yeah, it's even
The next one is in the book, 70.
number.
Damn it.
I do have a solutions manual, but not with me, so I can check it. Do you get 762? Multiply it out.
Yeah, 786.
12.213.
Yeah, you 12.2.
I put 12.21. Oh, you know what?
Oh,
I
just
probably
added the
took
extra.
like all, I took like
Precision.
every single extra number.
Yeah.
Yeah, all the way through. It's, we're right. It's close.
All right, I'm gonna stop this recording. I'll start a new one. For the next problem.